How's it going, everybody? In this video, I'm going to be talking about section 3.1, exponential functions. First, we must ask the question, what is an exponential function? Well, an exponential function is something that shows rapid growth or decay. So, for instance, 2 to the x is an exponential function, where if we substitute the number 1, right, if I make an xy chart, or x output art chart, 1, 2, 3, right? 1, 2 to the first power is 2, 2 squared is 4, 2 to the third is 8, right? You can think about like the handshake problem. When you shake hands with somebody, they go and shake hands with 2 other people, and then those 2 people go and shake hands with 2 other people. So now by the time that you've had the third handshake, 8 people have had the same handshake that you have given them, so you're passing your germs, so you must wash your hands very rapidly, well, not rapidly, very slowly for a minute with hot water and soap and all that good stuff, right? Exponential functions tell us that as long as we take care of certain things, we'll stay healthy? I don't know. So anyways, we're going to look at the graph of these things first. Oh, hitting the pause button doesn't do that on this. Whoops. Okay, so here are some possibilities of what the graphs could look like. So in the last example, when we had 2 to the x, notice our number here. This is called the base of your exponential. Your base is 2, base is 2, base, right? Not a bass player or a bass fish. Get it? I made a joke, but it's not very funny because it's called a bass. Anyways, if your base is bigger than 1, your exponential function is going to grow because it's going to keep multiplying by a bigger number each time, right? If it is less than 1, if we have a fraction like 1/2, that should be an x. It's going to keep getting smaller, so we're going to have a smaller fraction. So it will keep getting lower and lower too. With your parent functions, these are unit parent functions, you have a horizontal asymptote at 0. It will never cross that line because no matter how many times you multiply a positive number or a negative number by itself, you will always stay on the other side of 0. But on the top side. Yeah. Cool. And if you have a negative, flip it over the x-axis. Yeah. All right. Let's take it out. Sorry about all that. I'm tired. So it might be a little strange, but it's always strange. Anyways, so you can read all the instructions. Yeah. Make sure you read all of them. You're going to be telling me all of them at some point. So with the sketch, I notice I have a base of 6, so this number is bigger than 1. So for my parent function, it is going to cross something like that and go up. This negative x, it is with the x. So this is right back to what we had in chapter 1 with the stretch, reflect, move. Time is backwards. Something like that, right? So you're going to reflect this with the x, so it's going to go over the y-axis. So I'm going to reflect everything over the y-axis. So that will go up here, and that will go down here. Okay, now we have sketched our graph. We can tell you, ooh, dinner's here, hang on. Yummy, 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 I got love in my tummy. That's tasty. I ate so fast. Okay, so we finished graphing it for the domain. It's all your x values included, so it goes from negative infinity to positive infinity. So this is just going to keep going up and up and up and up forever, but it's going to continue to go left. So negative infinity to positive infinity. My range, it goes closer and closer to the asymptote, and then it goes up forever. My x-intercept, I have none because it never crosses. My y-intercept, it did not move, so if you plug in 0, 6 to the 0 is 1. So I have the 0.01. For end behavior, as x goes to negative infinity, f of x is increasing forever, so it goes to infinity. As x is going to infinity, f of x is getting closer and closer to 0. Now, for your increasing, decreasing neither, or not neither, well, it won't be neither in this case. Words. Read your function from left to right. It is going down the entire time. It will always, forever go down. So it is decreasing on the range negative infinity to infinity. Forever and ever. Okay, and you're going to do all these graphs the same way. If you have something that is greater than 1, then it is going to start out going up. If it is something less than 1, it is going to start out going down. Remember your parent functions. Remember where your asymptotes are. Oh, I didn't state where the asymptote was. Okay. Asymptote, sorry. Should be y equals 0. It did not move up. It did not move down. Anything like that. Cool. All right. And this one, all it asks for is describing the transformations that occur. So this is just talking about your stretching, reflecting, and you're moving. Miss backwards. She's still in the room somewhere. She still exists. She'll never go away. She's alive forever. She's immortal. So for this one, if I do stretch, reflect, move, the only thing I have is the -2. It is not with the x, so it is going to move it in the y direction. So I can say that this is moving it down 2. Ignore the fact that I just wrote out. I said down 2. Down 2. Okay. For the second one, stretch, reflect, move. This base, remember this base? This 4 right here is just your base. Just your base. It's not going to affect any stretching, shrinking, anything like that. So I don't have any stretching or shrinking. For reflection, I have one that is not with the x, or I have a negative that is not with the x, so it's going to flip it over the x-axis, so x-axis reflection. And then I have +2 with the x, so it's going to move my function to the left 2. Yay! Happy day. Stretch, reflect, move for my last one. This one is where I have a 2 on the outside, so I'm going to stretch the y values by 2. So y's by 2. I have a negative with the x, so it's going to reflect over the y-axis. So I have a y-axis reflection, and there's no plus or minus anything, so no moving. Cool, that's all it's asking for. All right, next thing we are going to talk about is interest. This is talking about monies and things increasing or decreasing at a rate that is at a exponential rate. Sorry, exponential functions rate. I'm sorry, I'm just tired. I can't talk. Ask me questions, write them down, write them in your notes, write it off to the side. What are you talking about, Mr. Pike? I have no clue. And then bring them to me and I will explain when I'm not as tired, because I love you people. So, A stands for your action, after the rate. Yeah. Okay, I'll come back to that one. P is your principal, or pretty much your starting value. And A, we'll call it your final value. Yes, there we go. Words, I can use them. A is your final value. P stands for your principal. This is just a 1. The 1 is a part of a formula. Yay, part of a formula. The R stands for rate. Make sure that if it is 20%, you write it as 0.2. Do not write it in percent. The N's, N is this N, compounded N times a year. So whether it's monthly, it's 12. If it's quarterly, it's 4, so there's 4 quarters in a year. Just like there's 4 quarters in a dollar. If it's daily, hopefully there's 365. Do not tell me it's a leap year and there's 366. We're not going to think about that because it's almost negligible anyways. And T is your time, and years. So how long you are going to be accruing this interest. Let's practice it. Oh wait, no, I have one more. Hang on. Okay, the other interest formula is continuously compounded. It is not n times a year, it is continuous. This is the formula. E, this is called Euler's number. E is about 2.718. Yeah, I think so. 18, I believe that's correct. 2.718. This guy, Euler, did a calculation of the limit as x goes to infinity for 1 plus 1 over x to the x power. So it is an exponential growth function. Biggest thing that's kind of cool about this is that you can take the derivative of e to the x and it comes out e to the x. And likewise, the integral of e to the x is e to the x. But you guys don't know anything about derivatives and integrals, so that's the only thing that is cool about, well, not the only thing, never mind. It's a cool number. It's kind of like on the equivalent of pi scale. It is an irrational number, and it is really cool. Awesome. Awesome. Yay, awesome. Okay, so R stands for the same thing. T stands for the same thing. P stands for the same thing. This is 2.718. Okay, so there's nothing new about that formula other than it is continuously compounded. Make sure you pay attention to the wording. Compounded n times a year. Continuously compounded. There we go. There it is. Yay. Now let's practice. Okay. make sure you take a second, pause the video, write it down. Yay, we did it. We paused the video and we wrote it down. Okay, so complete table using given values. I'm looking for A. This is talking about interest for all of these formulas. Notice I have an N. That is when I'm going to use the formula A times, oh no, P times 1 plus R over N to the NT. And it's just going to be a matter of plugging it in the calculator. Yeah, you can read that. Trust me. Just kidding. And then continuous, that's our A equals PE to the RT formula. Okay, so I'm going to take a second and just write my first one. When N is 1, all I'm going to do is substitute in the numbers. Oh, I didn't write my numbers. Hang on, let me write the numbers. Okay, now I have the numbers. Yay! These will always be given to you. I'm sorry that I did not write them before. My bad. My B, yo. Yeah. You know how it goes. So I'm given P, I'm given P, I'm given R, I'm given N, and I'm given T. So I'm just substituting the numbers. A equals P, which is 1,000. 1 plus R, make sure you convert this. This needs to be 0.045. Move the decimal twice. The 0.045 over N, which in our first case is just 1, to the NT, so 1 times time is 10 years. And then it's just a matter of plugging it in the calculator, making sure you are very, 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 very careful. Alright, so this is kind of a different calculator than what you guys have in school, but notice where I put the parentheses. Right, 1,000 times 1 plus 0.045 divided by 1 raised to the power of 1 times 10. Make sure you put your parentheses in this case so that way it follows the order of operations that you want it to. Your calculator doesn't have a brain, so it doesn't know what you mean until you tell it what you mean. So mine tells me, and it shows me that that is actually what I typed in. That's what I want it to look like. So cool, yay, I did it right. So my answer then, since I'm dealing with cash monies, you have 1,552.97 cents. Make sure you round correctly. Please. I know how to read numbers. Yay. So then we would have 1,552.97 cash monies. Cool. So you're pretty much just going to do the entire thing and just substitute in the other numbers. You'll put in a 4 right there. And right there. And then same thing with the 12, same thing with 365, right? And you'll come out with numbers. Okay, I'm going to do that real quick and write my answers so that you can check your answers as you do this too. Yay, I'm going to do it too. Okay, so hopefully that is what you got for all of your solutions. If not, go back. I promise you, if you just look at your parentheses again, you can never put too many parentheses. Just make sure you're putting them in the appropriate place. Okay, so for our continuous one, I have A equals PE to the RT, so I will substitute in P. So A equals 1,000 times E to the rate 0.045 times time, and I'm going to substitute that in my calculator. You have a button that is E to the power of something. You can use that button, or you can find E on your calculator as well. Either way will get you the appropriate answer. Okay, so again, I'm just showing you what it looks like in my calculator, what it should look like in your calculator. My calculator is going to spit out a nicer looking version of it, but either way, you should get the same answer. So there we go, 1568.31. So 1568.31, well, that is it. And that's pretty much all the notes that you guys have. It's just going to be a matter of practicing that stuff over and over and over and over and over and over and over. The more math you do, the better at math you get. The better at math you get, the more money you make, apparently, says an article by somebody that I read years ago. I don't know. But, yeah, you can do math. You'll do well. It's just figuring stuff out. Don't forget, you need to know your parent functions. You need to know your horizontal asymptotes. Horizontal asymptotes for these. Y equals 0. Maybe you want to write it, maybe you don't, I don't know. And you have the y-intercepts, it's always going to hit 1 if you plug in 0 for x. You need to be able to sketch them, do all that stuff. You need to be able to do all that stuff. And you need to be able to draw a giant monkey, of course. Dancing monkey, yay, dancing monkey. Everybody loves dancing monkey. Yay. Have a good night, guys. I'll see y'all in class. Bye-bye. Oh yeah, it still doesn't work. Bye-bye!